Our focus for this video is going to be the Triangle Exterior Angle Theorem. First, we're going to try to do an informal proof and kind of discover the Triangle Exterior Angle Theorem, and then we will look at some examples of how to apply it to solve for missing angles. So let's start off. Let's use some angle relationships we have learned to see if there's any relationship between the measures of the interior angles 1 and 2 and the exterior angle 4 in our example here, triangle PRQ. So we're looking at angle 1 and angle 2, those two angles there, and see if there's any relationship with those and this, what they call an exterior angle 4. So to get exterior angle, we simply extend one side of the triangle. So in this example, they've taken the segment BC and we've extended it on one side this way, and that's created this angle here is our exterior angle. So when there's more than one exterior angle for a triangle. There's actually 6 different ways we could do this, but typically we have 3 exterior angles per triangle once we've written the first one and we've shown the first exterior angle. So with this exterior angle, the rules are now we can extend each segment of the triangle one time, and you can only have one extension per vertex. So we've already used vertex C. So that means we can use vertex A, and I'm going to use segment AC. So we're going to extend this out this way. And so then you'd have another exterior angle here. And then I can use vertex B, but I can't use segment BC because I can't have 2 extensions from one segment. So we're going to extend segment AB this way. So there is our exterior angle. So that is how we get exterior angles. So my first question for you is, what is the relationship between the exterior angle 4 and its interior angle 3 in this example here? You should know the relationship between angle 3 and angle 4. What is it? All right, I hope you came up with that. Angle 3 and angle 4 is a linear pair, right? It's a linear pair, and you may have also said, well, since it's a linear pair, I know that those angles are supplementary. All right, can you use that fact to write an equation to represent those 2 angles measure sums? Write the equation now. Okay, I hope you came up with the measure of angle 3 plus the measure of angle 4 equals 180. Again, our justification is angle 3 and angle 4 form a linear pair, so we know they are supplementary. So that is our equation. Now, what do you know about the measures of all 3 angles within triangle PRQ? In other words, what do we know about the angles, measure of angle 1 and 2 and 3? Can you write an equation to represent the sum of the interior angles for that triangle? I hope you came up with the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. What's our justification? Yes, triangle sum theorem. So now we have 2 equations and they both equal 180. Can we write a new equation setting the linear pair angles equal to the 3 interior angles of the triangle? Can we write that equation? And then what would be our justification for doing so? So now we get the measure angle 3 plus the measure angle 4 equals the measure angle 1 plus the measure angle 2 plus the measure angle 3. What's our justification? Substitution property of equality. Think about it. They both equal 180, right? So I'm taking the measure angle 1, 2, and 3, and I'm just going, boop, replacing the 180 with it, right? Because they both equal the same thing. So that's the substitution property of equality. I substituted those angles for the 180 in the bottom equation and rewrote our equation. Can we now use our algebra skills for solving algebraic equations to simplify this equation a little bit more? I would like to solve for the measure of angle 4. In other words, I want this to be measure angle 4 equals what? And more importantly, I can't just do that willy-nilly, right? I need to have a justification for it. So what would be my justification for simplifying this equation? So I want you to come up with the equation and the justification. So in our original blue equation, we had the measure of angle 3 on both sides of the equation. So we've learned in algebra, if you have the same thing on both sides, you can subtract it from both sides. So that's what we do. We subtract the measure of angle 3 from both sides of the equation, and we get the measure of angle 4 plus or measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Our justification for that process is called the subtraction property of equality. So we finalize this. We now have a equation where we've solved for the exterior angle, and we can see that the measure of this exterior angle 4 equals the sum of angle 1 plus angle 2. And that will work for all situations with triangles where you have an exterior angle and these two angles here, which we're going to call remote interior angles. Again, remember, theorems are something that mathematicians have proven to be true. So we have the Triangle Exterior Angle Theorem. It's been proven by mathematicians. We just did an informal proof of it ourselves. So angle 4, again, is the exterior angle. And angle 1 and 2, we're going to call these the remote interior angles. So there are the two angles inside the triangle that are not adjacent to the exterior angle. So angle 3 is adjacent with angle 4. That's why 1 and 2 are called the remote interior angles. But that could change within this triangle depending on what your exterior angle is. So let's make sure you understand this concept of remote interior angles based on the exterior angle. So here's our example. We have a triangle there with 3 interior angles, A, B, and C, and we have 3 exterior angles, angle D, angle E, and angle F. All right, let's start off. Let's use angle D as our exterior angle. So now I want you to tell me, what are the 2 remote interior angles? So our remote interior angles are angle A and angle B. So I wrote the green equation there. The measure of angle D equals the measure of angle A plus the measure of angle B. Now let's throw a curveball at you. Let's say we're going to use angle E as our exterior angle. Can you now tell me what would be considered the remote interior angles for this triangle? So our remote interior angles change now to angle A and angle C when E is our exterior angle. Do you see how angle B is now adjacent to angle E? So the 2 other angles left over are angle A and angle C. So our equation would be that the measure of angle E equals the measure of angle A plus the measure of angle C. All right, one more. Let's say we use angle F as our exterior angle. What are the remote interior angles now? So when F is our exterior angle, our remote interior angles are angle B and angle C. Again, do you see how angle A is adjacent to angle F? Or you can think of it as angle A and F form a linear pair. So we're talking about the other 2 angles. So measure angle F equals the measure angle B plus the measure of angle C. All right, let's apply the exterior angle theorem to find some missing angles. So this first one here, yeah, you could probably do this in your head, but what I'd like you to do is, can you write the algebraic equation you would use to solve for the missing angle x, and can you go ahead and find the value as well? So our equation is simply x equals 64 plus 45. So we go ahead and combine the 64 and 45, and we get 109. So x equals 109 degrees. Let's take it to the next level. So on this one, I would like you to just write an equation for me how you would solve for y. What would be the equation to solve for y? So our equation should be 4y plus 7y plus 6 equals 116. So the 4y and the 7y plus 6, those are our remote interior angles, and the 116 is our exterior angle. So we can solve for y now. We simply combine like terms. We get 11y plus 6 equals 116. We use the subtraction property of equality to subtract 6 from both sides. So we get 11y equals 110. Then we use the division property of equality, divide both sides by 11. So we get 1y equals 10. All right, now we know the value of y, but wonder if I asked you, what is the measure of each of those angles? What's the measure of angle C? What's the measure of angle D? Can you find those values? So just like the other angle problems we've been solving recently, all we do is use substitution. So now that we know that y is 10, we just go 4 times 10 gets us 40. So angle C, the measure angle C is 40 degrees. To find the measure angle D, we go 7 times 10 plus 6, which gives us 76 degrees for the measure of angle D. All right, for our last example, let's throw you a little bit more of a curveball. So we have two exterior angles given in this problem, and they want us to find the measure of the interior angle P, but they've given us no interior angles. All right, so there's a couple ways we could drive on this one. So let's drive so we're all consistent. Let's go ahead and use the angle that's 130 degrees as our exterior angle, okay? I would like you to solve for P. So in this one, you had to use something else that you already knew in order to solve it. So some of you might have got stuck on this one. But the first step is you had to figure out that this interior angle here is 70 degrees. How do we get that? Well, we know it's a linear pair with the 110. So we know that those two angles are supplementary. So you simply go 180 minus 110, and you get that angle to be 70 degrees. All right, now we're in business. We have the two remote interior angles are 70 and P. So we go P plus 70 equals 130. We subtract 70 from both sides, and we should get P equals 60. Let's do the exact same problem, but we're going to drive a different way this time. Let's start with the 110 degree angle as our exterior angle. So we're going to use that as our exterior angle. I want you to do the same problem and solve for P. Okay, so first thing you had to do is you had to figure out that this one interior angle is 50. Again, we know that those two angles form a linear pair, so we know that they are supplementary. So we simply go 180 degrees minus the 130, leaves us with 50 degrees for the interior angle. Now we're in business. We know that the two remote interior angles for the 110 is P and 50. So P plus 50 equals 110. We subtract 50 from both sides, subtraction property of equality, and we're left with P equals 60. Same answer, but we drove a different way. So how are you feeling with this topic? Why don't you write a message for your teacher? Do you have any points of confusion? How are you feeling with this topic? Are you ready to do some practice problems, or do you need a little more instruction?